So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And in this particular channel of Unacademy, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 11 students, and this is lecture number 7 of fluids. And today we'll be talking about capillary action. Okay. Now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT exams, both mains and advanced. So for 7 years, I had taught in offline institutes, and I had been associated with some of the topmost offline institutes that you may have heard of. For past 1 year now, I've been teaching physics online here. All right, and now as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT exams that I took. And I also qualified the NTC Stage 2 examination, and I was in the top 1% in the NACP exam as well. Now, I've already coached many students to top ranks in the IIT exams, both mains and advanced, in my offline experience. And now I hope to continue guiding you guys to your dream ranks and your dream colleges. All right, so students who are worried about how to get the best possible education in this time where most of the students hardly have any access to education or educators, so there is a great opportunity for you. You guys can go for the Unacademy subscription. This subscription will give you benefits like live classes. You get to interact with your educators on a regular basis. Then you also have live polls and leaderboards in these classrooms. Finally, you have regular test series and analysis sessions. In very important because these keep you on your toes and keep you aware of your standing in the competition. So very important for a competitive exam like IIT. And of course, then you have live doubt clearing sessions. So this is one of the best features. Now I know doubts is something that troubles all the students a lot. Now all the Unacademy Plus courses have this feature that every fourth session in Unacademy Plus courses is entirely dedicated to your doubts. So after every three teaching sessions, one session is dedicated for doubt solving of students, where students can ask any doubts related to their theory, related to their concepts that they did not follow, related to any problem solving difficulties that they are facing. Okay, so that feature makes sure that your doubts are not piling up and your studies are going ahead smoothly. Next, apart from all these benefits, of course, you are also getting the chance to study from the best educators in the country from the comfort and safety of your home. I think that's a huge opportunity for all the students, and no student should miss out on this, right? Next, of course, so how do you get these benefits? So the first step towards availing these benefits involves for you to install the Unacademy app. Now, the moment you install the Unacademy app, you will unlock for yourself a lot of free features like free courses. So Unacademy app offers you a lot of free courses which anybody can enroll in just after installing the Unacademy app. Plus, yeah, we have special classes. So I am having special classes daily this week. So you can enroll in that absolutely free of cost. You don't need to buy any subscription for this. And then of course you have quizzes like the one we have on Tuesdays every week. So all these features are completely free of cost. So free features, no subscription is needed. Okay, all you need to do is install the Unacademy app, and you will be asked an invite code. So enter RD Live as your invite code, and that's it. With that code, you can unlock all of these free features. Next, of course, these features will give you an idea of how your preparation is going to be with the Plus subscription. So gives you a flavor of the Plus benefits. So once you decide that you want to take your studies to the next level, so hello AP, hi Amod Kumar, hello Rajesh, hi Mahi, how are you all? So how is everyone doing? So once you realize that okay, this seems nice, and I now want to take my studies to the next level, the next step is to get the Plus subscription. So to get the Plus subscription, you need to go to the Plus section of the app, select your goal as IIT and click on that Get Subscription button. Now, the moment you do that, you will be redirected to the payment page, where you'll find such a page where you will have a box that will say, "Do you have a code?" That is where you can enter this code RD Live. This code will give you a 10% off on all your subscription fees. Okay, whether you go for the Plus subscription or whether you go for the Iconic subscription. Okay, so you get a 10% off on both subscriptions using this code. Okay, so the fees of these subscriptions are as mentioned here, and you will also realize when you click on proceed to pay, you can also select a lot of no cost EMI options to break these payments into smaller parts so that you don't feel the burden of these payments as well. Okay, next. students who don't know what the iconic suppression is. So here is a bit about that. The iconic suppression is a relatively new offering by Unacademy, and this is something that will take your IIT JEE preparation to the next level with personal coaches. So from our team of experts, you will be allotted personal coaches, and these personal coaches will closely monitor your performance and mentor you throughout your IITJ journey. And along with all the benefits of the plus, you also get chance to attend a lot of extra IITJ workshops, receive expert guidelines from time to time, get a study planner, which I know a lot of you can use, and have regular test analysis sessions. So with all these features, definitely your JEE preparation will go to the next level and you will power through your IITJ journey. Students who have just entered class 11 and are wondering how to go about their studies for the next 2 years, so you do not need to worry. Hello Raj, how are you? So Unacademy now offers you a single one-stop solution for all your study needs by offering you combo subscriptions. So these combo subscriptions take care of your studies of class 11 CBSE, class 12 CBSE, hence your board preparation is done. Then you also get preparation for your IIT JEE Mains, IIT JEE Advanced. So everything that you are bothered about the next 2 years is taken care of by these subscriptions combos. Okay, so there are 4 combos that you can choose from. The first combo offers you the iconic subscription for IIT JEE and plus subscription for CBSE 11th and 12th. And this subscription starts at around 4,600 a month. Then you have another combo which offers you the iconic for all three. That is IIT JEE, CBSE 11th and CBSE 12th. And this combo starts at around 5,500 a month. Then you have a combo that offers you the plus subscription for IIT JEE and plus subscription for 11th and 12th. This combo starts at 3,000 a month. And then you have another final combo which offers you the plus for IITJ and iconic for 11th and 12th CBSE. This combo starts at 3,900 a month. So again, depending on your study needs, you can choose a combo that suits your needs, and then of course leave all the worries of studies behind. Okay. Next, students who are following us on the JEE English channel of YouTube and should be connecting with us on the Telegram app using this link. So that will make sure that you are receiving all timely notifications of every lecture and session happening here on this particular channel of YouTube. Because a lot of students give me the feedback that they have subscribed to the channel, they have clicked on that bell icon, they still do not receive timely notifications from YouTube and often miss a lot of sessions. So when you join us on this Telegram group, that won't be an issue anymore. Okay, so things will be very simple. You will be getting all timely notifications with this group, and then you don't have to miss out on any of the amazing content being provided here. All right, with all that information out of the way, let's get started with today's discussion of fluids, and we will today discuss capillary action. So, hi Motilal, how are you? All right. So again, we started our discussion of surface tension in the last class, where I told you how the surface tension phenomena arises. So I told you that the surface molecules have greater intermolecular interaction energy because they have to compensate for the asymmetrical force that all the surface molecules are feeling downwards. So to counter that, these guys develop stronger intermolecular forces, and that is why the free surface of the liquid starts behaving somewhat like a solid, okay, due to greater intermolecular interactions. And that is what causes surface tension. And I also told you now to create a surface. So you need energy also to bring a molecule from the bulk to the surface. You need to do work against the attractive forces of the bulk molecules. So I told you there are 2 ways of defining surface tension. So one was surface tension is defined as force per unit length, and this always acts perpendicular to the length. Okay. Then you have surface tension can also be defined as the energy, surface energy per unit area. Okay, both of them are dimensionally exactly the same things. 2 ways of defining the surface tension numerically. Okay, again, surface tension was a property of the liquid because it depends on the amount of interaction. The stronger the interaction, the greater would be the surface tension value. Okay, so it depends on the nature of the liquid, and of course depends on the temperature and presence or absence of impurities. So I think we had discovered all that in the last class. Why don't we start our discussion with some questions from yesterday's discussion then? So here's a question, and this was asked in IIT JEE, by the way. So this is a advanced PYQ. So this was asked in advance earlier. So we'll start with that, and let's see if you know, with our discussion yesterday, you can solve this. So you have been told that 2 soap bubbles A and B are kept in a closed chamber where the air is maintained at a pressure of 8 Newton per meter square. The radii of the two bubbles are 2 centimeter and 4 centimeter respectively. Surface tension of the soap water used to make the bubbles is 0.04 Newton per meter. Find the ratio NB is to NA, where NA and NB are the number of moles of air in the bubbles A and B respectively. Neglect the effect of gravity. So why don't you guys try this? Well, let's see if our discussion, yesterday's discussion, was enough for you guys to figure this one out. If you paid attention, this should be relatively easy only. Okay, don't worry about it. Okay, so give it a try. Let's see. So I hope everybody knows the ideal gas equation. So hint is you have to use the ideal gas equation here. Okay, so the hint. Okay, let's see how many of you can figure this out. Okay, try this problem. So let's say I'll wait for a couple of minutes for you guys to try this. Okay, AP already has an answer. Okay, AP. Good to see that you are trying. So yes. AP follows the lectures regularly. Okay. All right. 5.3. Okay. So two answers I'm getting as 6 is to 1, and one answer I'm getting as 5 is to 3. Okay. All right. Let's see if these are correct. So first of all, the pressure here, external pressure for both the bubbles is this. So with the help of that, I can find the pressure inside the bubbles. Okay, I know that the excess pressure PA minus P naught would be equal to 4T by RA. Okay, please remember why 4T, because these are air bubbles that we're talking about. So using this, what I can realize is P naught was 8 plus 4 into surface tension was 0.04 over the radius of bubble A, which was 2 centimeter, so 0.02 meters. So, what I'm getting is 8 plus 8, that is 16 Newton per meter square. 16 pascals is the pressure inside the bubble A. All right, S. Pandey also says 6.1, 6 is to 1. So three answers of 6 is to 1. Let's hope correct answer. Similarly, and can I say that similarly PB minus P naught would be also equal to 4T over R of B, which will give my PB as 8 plus 4 into 0.04 over the radius of this bubble is 4 centimeters, so 0.04. So that makes it 12 Pascal. Okay. So I've got the pressures in the two bubbles as 16 and 12. Okay. Now I know I can apply P1 V1 equals nRT. Okay. So can I say that PA would be equal to NART? Okay, again, I will assume that the temperature in both the bubbles is same because they are present in the same chamber. So that is yet another thing that you needed to realize. And you can say PVB should be equal to NB over RT. Okay, so this is my equation 1. This is my equation 2. Now I was supposed to find NB is to NA. So equation 2 over equation 1 will give me NB over NA. That would be equal to PB over PA. Now, all I need to do is just substitute the values 12 over 16, and uh, the volume would be proportional to R cube. Okay, so instead of here, I will have 4 cube, and here I'll have 2 cube. Again, I'm not converting this because in the ratio, the conversion factors would cancel themselves out. Okay, so what you realize is that this is 3 is 4, and then you realize this would also be 8. Okay, 2 to the power of 3. Okay, so I will have 3 over 4 into 8, which is in fact 6. Okay. So yes, 6 is to 1 is the correct answer. So well done, all you guys. So well done, AP, Raj, and Espande. So you guys have answered it correctly. So Amod, you thought it was 5 is to 3. So just go through the solution and let me know if you follow how we got 6 is to 1. Okay. This was an integer type question asked in JEE Advanced, by the way, to find this ratio. So the integer is 6. Okay. Let me know if you follow the solution. And in case you have any doubt, then also you can let me know. I'll go over that part again. All right. Is the solution clear, Ramod? Let me know. I think rest everybody already gave the correct answer, so I'm not too worried about this. Okay. Okay. So again, I hope those of you who did not find the correct answer have followed the solution then. Okay, this is a pretty simple enough problem. Okay. You realize even in advance, the problems are not too difficult if you know your basics. If you realize your common equations, then that's it. Let's move on to the next question then. This is again a question that was asked in advance. This is also an advanced PYQ. Okay, so I want to test that if you've been following the lectures, are you able to solve the advanced questions or not? Okay, let's see. So you've been told a uniform wire having mass per unit length lambda is placed over a liquid surface. Okay, the wire causes the liquid to depress by y. Y is much less than A, as shown in the figure. You have to find the surface tension of the liquid. Neglect the end effects. Okay. See if you can figure this out then. Okay. Let's see how many of you can figure this out. Again, a very simple one. Okay. Just try and think about it. So AP says lambda G A by 2y. Okay. Okay. Again, so draw an FBD of this. So what you will realize is if I talk about the FBD of this guy, so this guy is feeling what are the external forces acting on this? So it will feel a force of surface tension here. To feel a surface tension force here because it is in contact with the surfaces at two locations, and then it will feel its mg here. So I can say if this angle is theta, this angle is, let's say if this angle is theta rather, this angle will also be theta, correct? So here it is feeling a force of surface tension. Force of surface tension. So for equilibrium of the wire, what I can say is, okay, S Pandey is trying. Okay, Amod says it's tough. Okay, let me give you. Okay, Tanya also has this answer. Okay, let's see. Okay. So should I go ahead and solve or should I wait for one more minute? Let's wait for one more minute because two of you are trying. Let's give you some time to fix. Okay. All right. I think that time should be enough. Okay. Now this is very simple. Okay, guys. You don't have to worry about anything. What you can say is for the equilibrium of the wire, can I say let the length of the wire be L? Okay. Let the length of wire equals L. So what I can realize is therefore mg equals lambda Lg. And what is the force of surface tension? Force of surface tension is T into L. Now for equilibrium of the wire, what I can realize is that the net force in the vertical direction should be zero and in the horizontal direction again. So I can resolve this force into two components, correct? If I resolve this component into these two components, so these two will balance the force of mg and these components will cancel each other out. So all I need to do is that make sure that the vertical component of the surface tension force is able to balance the mg. Okay. What is the vertical component? So I can say for equilibrium, I can say that 2 times force of surface tension into sine of theta would be equal to mg. Correct? This angle was theta, the vertical component would have been sine theta. Correct? Okay, so therefore, what I have is therefore 2 TL sine of theta is equal to lambda Lg. Okay, L and L gets cancelled. Now I can also realize that since y is much less than a, as has been given to me. So can I say theta tends to 0 and therefore sine theta is roughly equal to theta, which is also roughly equal to tan theta. Correct. So I will use this approximation then, and I can now replace the value of sine theta as tan theta, which is y over a. Right. So that is what I'll do. Therefore, what I write is 2t into y over a would be equal to lambda times g. So from here, I will get equals lambda g a over 2y. The correct answer. So yes, absolutely correct. Lambda GA over 2y is the correct answer. Well done, AP and Tanya. You guys have given the correct answer. Again, you realize these are JEE advanced questions, and JEE advanced questions are also very simple if you just follow the basics. Okay, so good to see you guys solving this. So you guys have been following the lectures, and I'm glad that following the lectures you are able to solve IIT JEE advanced forms. So well done, guys. All right, next, now we will shift our focus to another thing. So we'll talk about cohesive forces. So what is cohesive force? The force of attraction between molecules of same kinds or same nature is called cohesive force. So for example, you have water in this glass, so there must be some attractive force between the water molecules. Okay, if there was no force, this would have been a gas, right? So that kind of force is called cohesive force. Similarly, when you have glass molecules here, so these glass molecules also have an attractive force amongst them. So this is called cohesive force, the force between the same kind of molecules. Okay, so that is what is able to hold this pen. So when I'm holding this pen here, what is holding this part? Okay, if I talk about this certain part, the gravity is pulling this down, but what is holding this up? So the adjacent molecules are attracting it upwards. Okay, so they are attracting it with cohesive force. It's the cohesive force that is responsible for any object maintaining its shape and maintaining its size. Okay, so now when two liquids coalesce into one, two liquids, when they are two drops, in fact, when they are brought in contact, it turns out coalesce into one. So you must have seen this. If you have one drop, if you have second drop, if you just bring them in contact, due to the attraction, they combine and they form a one single drop. So that is also a result of cohesive force. Again, you will realize it is also very difficult to break mercury into small droplets because of large cohesive force between mercury molecules. So that is what cohesive force is, and these are the effects of cohesive force. So the cohesive force helps two drops to join, and that is why you realize when you when you pour mercury anywhere, uh, it is very difficult for you to break mercury into small drops, okay, because of large cohesive force, okay. Next, you have something called adhesive force. So adhesive force is what? It is the force of attraction between molecules of different kinds, okay. So I told you, when I pour the water, so I don't know if you can notice this, that there are some water molecules which are sticking to the side of the glass. Okay, when I drink water, you will realize some water molecules are sticking here, are sticking here. Okay, you probably can't see this, but that is what adhesive force is. That is the force of attraction between glass and water molecules that makes water stick to glass. Okay, so that is what adhesive force is. Again, you would have noticed this adhesive force, as I said, here is an example. So adhesive force is the one that enables us to write on blackboard with the chalk. So whenever I'm writing on a blackboard, so what is it? Why does the chalk stick to the blackboard? So it sticks due to the adhesive forces. Okay. Okay. So Arjun says, "Sir, I have a question." Okay. So what is Arjun's question? How do teachers find the answer for a question which they have never seen ever? Like say during a paper discussion, how exactly? So okay, that just comes through problem solving. No, problem solving. I have solved so many problems. So if you bring me a question, I'll think about it, analyze the situation, so and figure out how to solve it. Okay, how do you solve paper question in papers? How would you solve a question in an exam? Okay, you have to know your fundamentals. You have to understand them well enough so that and you should be able to think of it. Okay, if you can analyze the situation, if your fundamentals are clear, you'll be able to answer it. Basically, that's how I do it. Okay, I don't know about others. It's clear fundamentals and years of practice. So you realize we teachers have so many years of practice. So I've been teaching for 8 years now. So I've been solving problems of J related problems for 8 years. Okay. So I've solved so many problems, so many problems. So with practice, you develop approaches, right? So you know what kind of approach would be applicable in what kind of problem. Now, even if there is an entirely new situation, then also see, I mean, problem solving is what? You are given a situation and you have your tools of problem solving. So you think about the situation, analyze, and then try and relate what tools you can use. Okay, tools of problem solving. What are the tools of problem solving? The theory that you study. So tools may include your Newton's laws and our momentum conservation, energy conservation. These are the tools that I have for solving any problem and etc. Angular momentum conservation, whatnot. Okay, so I will look at a situation and think about it, and then think about my tools. Okay, these are the tools that I have. Either I can use Newton's laws, or I can use momentum conservation, or I can use energy conservation. So I'll try and fit what tools fit into this situation, given situation, and again that would be very clear from your practice. If you've practiced, you know in what situation what works the best. Okay, that is it. Simple as that. Okay, so you can ask me a question that I've never seen, and that is what I'll do. I'll just go back to the basics. Think about the situation. Think about my tools. Think about what all tools I have, okay, and I try and relate that. Okay, I mean that isn't that what I probably did as a student also when I gave the ITJ exam. Obviously, so ITJ most of the problems that you see are new problems you've never seen. So as a student also you do that only. It's nothing different. Okay. Next, it is due to the force of addition that water wets the glass. As I was telling you. So if you could see this, you would have seen small drops of water sticking to the glass surface. Probably not very visible from here. And you will realize mercury never wets the glass. Okay. So if you have a glass surface, if you pour water on it, and if you tilt it, so most of the water will fall out, but there will be a layer of water which will stick, and that is why what we say that water can wet glass. Okay, now that happens because the adhesive force between glass and water is greater than the cohesive force between water and water. Okay, so let's take up an example. Now, let's say you had a glass plate like this, you tilted it, and you poured some water on it. So you will realize there will be a small layer of water which will stick. while most of the water will fall off. Okay, so if you add this, most of the water will fall off, but there will be a small layer which will stick to it. Now that layer is sticking because the glass molecules are pulling the water molecules with adhesive forces. This layer is being pulled by the force of gravity, and so every molecule is pulling the molecule near it also. However, when these molecules are trying to pull this layer, this layer is feeling two forces. One, the molecules which are falling. Okay, so the force of gravity plus the force due to these molecules plus the force due to this glass. Okay, now the glass and water adhesive force is very strong, and that is why these molecules are able to remain, in touch with the glass, while this entire layer will flow away. The layer will flow away. You will see a small layer of water will stick to the glass. On the other hand, if you did the same experiment with mercury, then that does not happen. Why? Because if you had a layer of mercury now, mercury has very strong cohesive forces. Okay, and the adhesive force between glass and mercury is not that strong. So when the molecules of mercury are flowing off, they will pull these molecules. They will not let it stick with glass, and hence mercury does not wet glass. Okay, so again, wetting, whether a liquid can wet a solid depends on the relative strength of adhesive forces and the cohesive forces. So let's make a note of that here. Note, if cohesive forces are stronger than adhesive forces, the liquid does not wet the solid, and vice versa. So it's the other way around. If the adhesive forces are stronger than cohesive forces, then such a liquid can wet such a solid. Okay, so wettability is actually determined by relative strength of adhesive and cohesive forces. All right. So why we are discussing this? Because we are building up to our discussion of capillary rise. Capillary rise eventually happens because of adhesive forces and cohesive forces. Okay, the relative nature of those. Next, we'll talk about angle of contact. So whenever a liquid surface touches a solid, then the shape of the liquid surface near the contact is generally curved. Okay, so as you can see, normally if you place a drop of water here on a glass surface, or let's say any flat surface, and it will take such a shape. Okay, now the angle between the tangent planes or the solid surface lying inside the liquid volume and the liquid at the contact is called the angle of contact. Okay, so here I've drawn two tangents. Okay, so take a look at that. So one tangent is along the liquid surface at the point of contact. So this is the point of contact, edge of contact. So one is a tangent to the surface, another is tangent to the solid. One tangent to the liquid surface, another tangent to the solid surface. Now you could have had two tangents, right? So either you could have had this, or you could have had this. So two tangents were possible. So we always consider the tangent which lies inside the volume. Okay, not this one. This is not it. We talk about this, and the angle between these two tangents is what you call the angle of contact. Okay. Chinny King says, is Unacademy subscription available in English? Okay, so there is no language for the subscription. Once you get the subscription inside, you will have courses which are both in English and Hindi. Okay, English and Hindi courses are there. So you just need to get the subscription, and then you can choose whatever language courses you want to enroll in. Okay. So Unacademy subscription provides you access to all the plus courses that are running on the Unacademy app by different educators. Now, most educators take classes in Hindi, but some educators do take classes in English also, like me. Okay, so that is what you can do. Once you have got the subscription, now you have the option. You can attend English classes also. You can attend Hindi classes also. There are a lot of other some courses happening in other regional languages also. You can attend those also. Okay, okay, Srini. So there is no language for the subscription. Once you get the subscription, everything, all the languages, you're free to choose any language of your preference. Okay, right. So that is what we call angle of contact. Now you will notice that if the cohesive forces between liquid molecules are greater than the adhesive forces between liquid and solid, then the contact angle is obtuse and vice versa. So what happens is that if you talk about liquid molecules here at the surface, so the molecules here at the surface are feeling two kinds of forces, right? So they are feeling a cohesive force due to the bulk of the liquid, and then they are also feeling a force due to the solid below it. Okay, so maybe in this direction, net force would be in this direction. Okay, so whatever be the resultant, you realize if this force is stronger, then the net resultant would lie somewhere here. Okay, so the resultant force on these molecules would be a vector sum of these two. Okay, now depending on which one has a greater strength. So if this was a smaller force, then the resultant would be closer to here. So this would be the resultant force. And you know the liquid surface always aligns itself perpendicular to the resultant force. Again, remember your basics. If the free surface of the liquid, because it cannot withstand any shear stress, will always align itself perpendicular to the net resultant force. So that is why you see the contact angle in such cases is greater than 90. On the other hand, if you had this molecule which is feeling two forces again due to this cohesive force due to this bulk and adhesive force due to this. So if this force was very high, if the force of addition was very high, so you will realize in such a case the resultant force would be that here. That is why you realize that the liquid surface, free surface of the liquid, will now align itself like this. Okay. So then you realize that contact angle is less than 90. So that is how the angle of contact is decided. Okay, angle of contact depends on the relative nature of the two forces. Okay, all right. So here, if the contact angle is 90, that just means the two forces are exactly equal. Okay, so you have cohesive forces acting like this. You have the adhesive forces acting like this. If these two are absolutely equal, then turns out the resultant is in this manner, and that is why the liquid makes a 90-degree angle of contact. Okay, so depending on which force is larger, you have different contact angles. So please remember, if the cohesive force is greater than the adhesive forces, then contact angle is obtuse and vice versa. Now again, now that will also tell you about whether a liquid can wet a solid or not. Okay. Now you realize if the angle, so the angle of contact between a solid and liquid decides the wettability. A acute angle implies that the liquid will wet the solid and vice versa. Acute angle means that the adhesive force is greater than the cohesive force, right? So here I know adhesive force is greater than the cohesive force if such an angle is getting formed. Okay, so definitely this kind of liquid will wet the solid. On the other hand, here I know cohesive force is greater than the adhesive force. So here such a liquid cannot wet that solid surface. Okay, so that's very simple, very basic. So if you know the angle of contact, you can judge whether this liquid is going to wet that solid or not. Now, next we will come to the shape of the meniscus again. So whenever you have a tube and in which you keep a liquid, then you must have seen that the meniscus takes different shapes. Okay, you must have done experiments in your labs. Okay, so if you have a tube, glass tube, let's say, and if you fill it with water, you would have noticed that the water surface actually forms meniscus like this. Okay, a concave surface. The surface forms concave surface. Must have noticed this. Okay. So whenever we fill this also with a liquid, you know that we notice the markings at the meniscus. This is where you decide the height. Right? You must have done this in your labs. If you guys go to labs, that is. So why does that happen? Why is the meniscus curved like this? So that is also happening due to the relative strength of adhesive and cohesive forces. So when the adhesive force between solid and liquid is more than the cohesive force Q between the liquid and solid molecules, like glass and water, the shape of the meniscus is concave and the angle is less than 90 degree. Again, it's the same thing. To see here, it is feeling two forces. Okay, it is feeling two forces. One, the cohesive force due to water molecules, another, the adhesive force due to glass molecules. If this adhesive force is way stronger, you see the resultant is here. So the resultant is here. So the free surface is like this. And that is why you have a contact angle which is less than 90. So if you have a contact angle which is less than 90, so the shape of the meniscus would be concave. On the other hand, in case of glass mercury, you will realize that the cohesive forces are way stronger. So the resultant makes this angle, and that is why you have free surface which aligns itself like this, perpendicular to the resultant, and here you have a convex meniscus. Okay. So again, remember this: if adhesive force is greater than cohesive force, then concave meniscus. Concave meniscus also implies theta, which is the angle of contact, being less than 90. Okay, and if you have cohesive forces which are stronger than adhesive forces, then you will see a convex meniscus. Okay, and theta would definitely be greater than 90. Okay, so again, the relative strength of adhesive and cohesive forces decides the shape of the meniscus. Okay, so again, this has been explained here, but I showed you also. Next, we'll talk about capillary action. Now, the surface tension causes elevation or depression of a liquid in a narrow tube. Okay, why narrow? We will talk about that. Or capillary. So a narrow tube is what we call capillary, and if you dip a capillary in a liquid, you will realize either the liquid will rise up or the liquid would have gone down, depressed down. So this action is happening due to surface tension forces. Okay, and this is what we call capillary action. Okay. In case of glass and water capillary, the water rises. In case of mercury glass, the you will see the level of mercury inside the capillary would actually dip. Okay, so I don't know how many of you have seen this. You would have seen this, but I don't know if too many of you have seen this. But that is an interesting thing. You can maybe try it later sometime. Now the radius of the capillary tube, if the radius of the capillary tube is r and theta is the angle of contact, then the height of the water column in the capillary is given by this formula. Okay, and we can try and prove this also. So let's assume for the sake of simplicity right now that the surface is the liquid has risen up by a height h. Okay. So when it rises up to a height h, why it does, I will tell you that also. But let's say that it has risen to a height h and now it is in equilibrium. So what I can say is let's make an video of this. Okay. So here there would be a layer of water molecules which would be stuck here, and these guys would be feeling a force of surface tension. Okay, this sticks to the glass due to the adhesive forces. Okay, and this layer is pulling the rest of the water-free surface by surface tension. Okay, now surface tension will act along this line only. So if you realize this angle was theta, which is the contact angle, this angle would also be theta. This angle would also be theta. So this is one force that this is feeling. Then what are the other forces that it is feeling? So this liquid in the capillary would be feeling some force due to the atmosphere. It would be feeling some force due to the pressure here. Okay. And it would be feeling some force due to mg, force of gravity. These are the four forces that this liquid inside the capillary is feeling. Okay. So we are making the FBD of the liquid column inside the capillary. Okay. FBD of liquid column inside the capillary is as shown. Now you will realize. So let's that the pressure here, in fact, this P would be equal to P naught because the pressure here would be P naught, right? This is also a free surface. And at the same horizontal level, all the pressures have to be same. So you will realize P is nothing but equal to P naught. So if I write all the forces, if I write all the forces, so what I can say for equilibrium of this column, for equilibrium of this liquid column, what I can say is all the forces should be balancing each other. So you have downward forces which are P naught into the projected area, okay, into pi small r square, r being the radius of the tree, plus mg, and mg can be written as pi r square h rho. Okay, this should be equal to the upward forces which are the force of surface tension. Force of surface tension acts in 2 pi r length, this into cos of theta plus p naught into pi r square again, okay, which is the force of the pressure below, from the liquid below the capillary section liquid. Okay, so please note that we are drawing the FBD of this portion of this, ignoring the volume of the liquid in the meniscus. Okay, so we have drawn the FBD of this. Now, what you will realize is that okay, this get cancelled, and what I realize is that from here, what I realize is H would be equal to 2 cos theta over rho r. That is what your height of capillary rise. Now, you already know that t is very, very small usually. Okay, the value of t is of the order of 10 to the power minus 10, minus 2, 10 to the power minus 2. Okay, now you realize that rho is very, very high for water. Okay, 1000, and g of course is 10. So that is why if the r is very small, then only you see a rise. You see a significant rise. Otherwise, the rise in capillary is negligible. So you might have wondered, why does liquid only rise in a thin capillary or in a capillary? Why not in thick tubes? In thick tubes, the effect of capillarity is negligible. Okay, because of the large radius. If the radius is large, you realize the height would be tending to zero, and that is why you see capillary rise only in thin capillaries. Okay, and this is the proof of the formula of capillary rise. So here, of course, theta is the contact angle. Okay, rho density of liquid, r radius of capillary tube, and of course G is the surface tension. G of course is the equation to the gravity. Okay, so this is the formula, this is the proof. Please remember, very, very important. Okay. Now there is an alternate method of also proving this. Okay. There is another method of proving this. So now we will talk about that. We'll try and prove this same expression using another method. Okay. So let's talk about the alternate proof. Okay, so in the alternate proof, I will first try to relate the radius of the meniscus to the radius of the tube. Okay, so imagine the meniscus is a part of some spherical portion. Okay, now if I draw perpendicular from here and if I draw perpendicular from here, so these perpendiculars, these are essentially normals. Normals will meet at the center of this, uh, center of the sphere of which the meniscus was a part. So can I say that this distance would be r? Okay, and this angle was the angle of contact. So can I say if I make this triangle? So since this angle is theta, this angle would be 90 minus theta, correct? And you will also realize that this entire angle, okay, so this angle will also become, angle will also become. So if you look at this triangle, look at this triangle, you realize this base is R, this hypotenuse is capital R, and this angle is theta. Okay, this angle, both are theta. What you realize is that the relation between capital R and R is that capital R, which is the radius of the meniscus, is equal to small r over cos of theta. Correct? That should be visible. Okay. Because this entire angle was also 90. This entire angle was theta. This you know is 91 theta. This also becomes theta. Okay. That's what I want. That is how I wanted to relate these angles. So now you realize that the radius of the meniscus is r over cos theta. Okay. So if the pressure here is P naught, okay, so let's talk about the pressures at different points. I know the pressure here is P naught, and let's say the pressure here is P. So since I am crossing the liquid surface from the concave side, I know the pressure will reduce. Can I say P would be equal to naught minus 2T over R? Great. If you remember our discussion from yesterday. And now I will also realize if I reach here, if I come down a height h, here also the pressure was P. So here the pressure was P naught. So from Pascal's law, at the same horizontal level, the pressure again has to be P naught. So I can also say that also P plus rho GH should be equal to P naught. Okay. So now I can substitute the above value and realize P naught minus 2T over capital R plus rho GH will be equal to P naught. So here P naught and P naught will get cancelled. And what I realize is H is 2T over R rho G. Again, I can substitute the value of R from here. And what I realize is that I get the same expression, P cos theta over rho R G. Okay. So this is an alternate method of solving this, and you should definitely remember this. JEE Advanced has asked 2-3 questions where this relation was important and used. Okay, very important. This is the relation between the radius of the tube and the radius of the meniscus and the contact angle. Okay. JEE Advanced has asked at least 3 to 4 questions where this relation was used. Okay, without knowing this relation, you wouldn't have able to solve it. So very, very important relation, and this is an alternate proof. Again, so no matter how you prove it, you will get the right result as long as you're doing the correct thing. This is the great thing about physics. Okay. And you can get to the same answer by different methods as long as you're doing everything correctly. So that let's move on and let's talk about special cases. So there is one special case where if the angle of contact is 0, then what you do is we add a correction for the weight of the liquid contained in the meniscus. Okay, and we get this final expression. Now, how do I get that? Let's say, so till now, when I was drawing the FBD, you realize we had ignored this volume. So far, we were ignoring the volume contained here. So when we were taking mg, I was taking mg as pi r square h. Right? So that was the volume of this. How about the volume here? So we had ignored so far the volume contained in this curve. So if I wanted to add this volume also, then if I wanted to add this mass also, then I first need to find the volume of meniscus. Okay. The volume of the meniscus is not very easy to find unless the angle is 0. For a 0 angle, the meniscus volume would be very easy to find. So what happens is that if this angle is 0, then your meniscus is essentially a hemisphere, correct? So if meniscus is hemisphere, now you realize if you talk about this entire volume, you know this is a cylinder of radius r. Capital R in this case becomes equal to small r because cos is 0, cos theta is 0. In this case, capital R is equal to small r, and what you realize is that you have this entire thing, which is a cylinder of radius r and height r. Now, if I remove the volume of the hemisphere, I will get at the volume of the meniscus. So from here, volume of meniscus, volume of meniscus. That becomes pi r square into r minus 2 by 3 pi r cube. So that is pi r cube by 10. So if I added this volume also into our equation earlier, you realized what we said was that if I balance the forces, if I balance this forces, then this force, which was the weight, should be equal to this force, which is the force of surface tension. So here now in the weight term, I will add another term, which is the weight of the volume liquid contained in meniscus. So now I will write, including this volume, including this volume, I can say is that T into 2 pi r cos of theta would be equal to pi r square h to rho g plus pi r cube by 3 rho g. Okay. So hello Shiv. Shiv says, sir, can I start mechanical properties of fluids if I had not done rotational motion, gravitation? Yes, absolutely. 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 Surface tension and viscosity have got hardly anything to do with rotation and gravitation. Okay. If you know your Newton's laws, mostly you are just using Newton's laws. Okay, here. And you need some bit about energy. Okay, that's about it. Work energy and Newton's laws. That's about it. If you know these two things, then you can study surface tension and viscosity. Okay. There's not much need of rotational motion knowledge or knowledge of gravitation. Okay. So again, now you will realize pi r, so it cancelled. And now you will realize h comes out to be 2t cos of over rho r g minus. Right. That is, so if you include the volume of the liquid in the meniscus, then you have this correction, or the height reduces by r by 3, where r is the radius of the tube. Yeah, I think I did answer you, Shiv. No, there is absolutely no need for knowledge of rotation for studying surface tension and viscosity. Okay, don't worry about it. Okay. So again, this is a special case that you need to remember. There are sometimes they ask you, especially in mains, they can ask you question about this special case. Okay. हाँ, so that's good enough. That's good enough. उससे ज़्यादा की ज़रूरत नहीं है. क्या लिक्विड में सरफेस टेंशन विस्कोसिटी में उससे ज़्यादा की ज़रूरत नहीं है. क्या एनएलएम और डब्ल्यूईपी आता है तो बहुत है. That is more than enough. Next, we have another special case. So what if the length of the capillary is insufficient? Then what happens? So then turns out the radius of the meniscus changes in order to prevent overflow. Okay, so what happens is that imagine this formula could have given you any value. Okay, maybe let's add a page. So what you realize is that the height of liquid rise depends purely on the radius of the capillary tube, right? I can say since h depends on the radius of the capillary tube and not the actual height of the capillary tube. What you realize is, h was 2t cos of theta over rho r g. So you realize this can have any value. So suppose for a case, suppose we are using capillary of radius r, but height dash which is less than h. अब क्या होगा अगर मान लो, suppose if your formula tells you that will be let's say the liquid will rise up to a height of 10 centimeter and you got a capillary which has a height of 5 centimeter only. So what do you think when you dip such a capillary in the liquid, what will happen? That is a tricky question. That is a very tricky question. A lot of people get confused about this. So the question is that imagine that you got a container filled with water and you got a capillary which has a smaller length than the uh, height to which it is expected to rise. Let's say this is h dash and h is somewhere till here. The expected height of capillary rise was still here. Then what do you think will happen? Now that's a very tricky situation. Now most of you will think that a liquid will start to overflow. Okay, so it will come here. It wants to go to a height h. Maybe it will become a fountain. Maybe you will have a fountain of height h. Okay, that is also what some people might think. Okay, now here is the problem. Here is the problem. If that were possible, if imagine that were possible, then the problem is I could have made a system. I could have made a system wherein I would have kept one container, got with here, inserted a capillary, okay, gotten a fountain of water and collected it here in a second container. Imagine, okay, and then added another capillary. So this is an interesting paradox. This is a very interesting paradox that was asked. And then added another capillary here. Added another capillary here. Gotten another fountain. Collected the water above, and so on. You realize if I have such a series of capillaries and tubs, then I can make the water rise without doing any external work. Where is that energy coming from? Where is that energy coming from? कहाँ से आ रही है ये energy? So that would have been a violation of energy conservation. Okay, this kind of phenomena, if possible, violates energy conservation. Okay, you could have gone on gaining potential energy by without doing any work. Okay, so instead of using a pump for your household, let's say when you get a household water supply and you have to make the water reach your tanks, okay, water tank at the roof. Now you could have just added a series of capillaries, and you won't need any pump to power the water up. The capillary action would have caused the water to go up and get settled there, right? Without you having to do any work. तो फ्री का पावर सोर्स मिल जाता है हमें जो कि पानी को विच इज helping water gain potential energy without doing any work. So that would have been a violation of energy conservation. Okay. So what actually happens is first you need to understand why the liquid was rising in the capillary. So far we discussed if the liquid strategy का क्या मतलब कौन सी strategy किस किस respect में strategy strategy तो simple English word है यार strategy का word Google कर लो क्या है मतलब किस 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 उसमें कह रहे हो कॉन्टेक्स्ट में. So the point is, as I said, so far we had discussed that okay, the capillary inside capillary the liquid is rising, and if it rises to a height h, then I'm trying to find the equilibrium condition and determine the height h. We never discussed why the liquid was rising. Okay, so now you can try and decide that. Let's take our discussion again one step forward and let's see why the liquid actually rose. Why would the liquid rise? And there lies the answer of what will happen with a liquid of sufficient height. Okay. Suppose you had this container, you had water in this, then you had a capillary. Now, what happens is that when you see a level of water here, then this water is feeling forces due to the molecules above. Okay, the molecules above are attracting this, and the molecules below are also attracting this. Okay, now for glass and water, the adhesive forces are stronger. You know that. So the force due to the glass molecules above this actually win, and this liquid starts to rise at the edges. Okay, the liquid which is in contact with the edges starts to rise. So you see a meniscus being formed. Okay. What happens is, as a result, a meniscus starts to get formed. Now, the moment meniscus gets formed, you realize the pressure here will drop, and the pressure here is higher. If you talk about a small layer, the pressure here is P naught, and the pressure here has dropped. So on this small layer of liquid, the net force is upward. So that net upward pressure difference would cause the liquid to start rising. Okay. Now that is happening because the meniscus is getting formed. And this will, again, the moment it rises, it will try to push the meniscus, flatten the meniscus. Okay. And then due to the adhesive forces, the meniscus will be pulled further up. So this thing will keep on happening. The meniscus, the water rising will try to flatten the meniscus. The adhesive forces of the molecules above will again form the meniscus and then again help with the push. Now, what happens is if your liquid was of your capillary was of insufficient height, then what happens is that if there is a difference in pressure, okay, so here also if the meniscus contact angle does not change, then you realize the pressure here and pressure here would be different. So it will feel a push. That push will make the liquid rise. It will change the surface from this to this. Okay. But now to again maintain the shape of the meniscus and maintain the contact angle, what you realize is that there is no molecules of glass available here. Correct. So that is the problem. Every time this happens, there should have been glass molecules above which would have pulled this meniscus and make it curved again. So since that is not happening, so what happens is due to this pressure difference, the meniscus shape will change and the liquid will stop here. Okay, so that is the explanation from the Newton's laws point of view. Okay, and I hope you follow. Strategy का क्या मतलब है in studies? Strategy in general किसी भी चीज को भाई सक्सेस पे पाने के लिए कुछ एक अपने सीक्वेंस ऑफ इवेंट्स सोचा है कि हाँ भाई इसको ऐसे करेंगे तो ज़्यादा सक्सेस मिलेगी। ठीक है, तो अब इन स्टडीज यार एक ही स्ट्रैटेजी, मुझे तो एक ही स्ट्रैटेजी पता है, हार्ड वर्क। ठीक है, बाकी लोग यार बताते हैं स्ट्रैटेजीज वगैरह। हाँ, तो यार वो स्ट्रैटेजीज का कोई खास मतलब होता नहीं है, ऐसा कुछ है नहीं खास कोई बहुत तरीका है। देखो देखो, एक एक एग्जाम है भैया, आईआईटी जेईई कॉम्पिटिटिव एग्जाम है, इट्स अ कॉम्पिटिशन। ठीक है, अब कंपटीशन में क्या है, कंपटीशन में क्या है कि टू डू वेल यू हैव टू डू बेटर देन अदर्स। है ना? तो ये जो स्ट्रैटेजीज वाले वीडियोस बहुत सारे होते हैं यूट्यूब पे जो लाखों लोग देखते हैं, तो आपको क्या लगता है अगर कोई भी स्ट्रैटेजी ऐसा कोई शॉट है और वो स्ट्रैटेजी अगर सबने देख लिया, 1 लाख लोग वही स्ट्रैटेजी लगा रहे हैं, तो वो एज बचा क्या? 1 लाख लोग वही स्ट्रैटेजी यूज कर रहे हैं, तो आप कंपटीशन वाइज तो वो न्यूट्रल हो गया ना। हाय दैशिक, हाउ आर यू? सो ये सब टाइम वेस्ट होता है स्ट्रैटेजी वीडियोस, है ना, कि पढ़ने की ऐसी स्ट्रैटेजी बनाओ वैसी स्ट्रैटेजी बनाओ, दैट्स अ वेस्ट ऑफ टाइम। एक ही स्ट्रैटेजी है, मेरे को तो एक ही एटलीस्ट पता है। अगर ऐसा कोई सीक्रेट, अनलेस कोई सीक्रेट हो जो सिर्फ तुम्हें पता है, दुनिया में किसी को नहीं पता, ठीक है, और ऐसा कुछ होता नहीं है, ट्रस्ट मी, मैं अपने एक्सपीरियंस से बोल रहा हूँ, मैं खुद आईआईटी का एस्पिरेंट रह चुका हूँ, मैंने खुद पढ़ाई की थी, खुद आईआईटी जेईई क्रैक किया है। कोई स्ट्रैटेजी नहीं होती, एक स्ट्रैटेजी के अलावा हार्ड वर्क, पढ़ाई करो, फंडे क्लियर रखो, प्रैक्टिस करो, ठीक है, क्लियर फंडामेंटल्स। and practice. That's the only strategy that you should stick to. That's it. है ना? बाकी सब बकवास है। बाकी कोई कुछ भी अगर आपको बोल रहा है स्ट्रैटेजी ये कर लो तो ऐसा हो जाएगा। अरे बोर्ड के लिए काम कर सकता है वो। आई एम डूइंग ग्रेट देशिक, थैंक यू फॉर आस्किंग। देखो बोर्ड के लिए हो सकता है, बोर्ड में कोई कहते हैं कि हाँ, हाँ, ये देखो पैटर्न ऐसा है कि यही क्वेश्चन ज़्यादा आते हैं, तो यहाँ से कर लो 90% नंबर आ जाएँगे, वो एक अलग बात है। इफ यू टॉक अबाउट कॉम्पिटिटिव एग्जाम्स लाइक जेईई, है ना? ऐसा नहीं हो सकता ना यार, बोर्ड में देखो लाख लोग के भी 90 से ऊपर आ जाएँगे, कोई दिक्कत नहीं है, ये आते ही हैं। 10th में when the CGPA system was there, I think more than 1 lakh people would get 10 on 10 GPA, है ना? और सब खुश। कंपटीशन में इन IIT JEE ऐसा नहीं होगा। वहाँ कोई तुमको बता सकता है व्हाट इज़ द स्ट्रैटेजी टू गेट 10 आउट ऑफ 10। ओके, सो ठीक है, 10 आउट ऑफ 10 GPA आप 10th में ले आए और उसका कोई पॉइंट नहीं है कंपटीशन में जहाँ लाख लोगों का 10 आउट ऑफ 10 है। यहाँ पे रैंक 1 और रैंक 1 लाख में ज़मीन आसमान का अंतर हो जाता है। रैंक 1 वाला IIT जाएगा, रैंक 1 लाख वाले को कोई ढंग का कॉलेज नहीं मिलेगा, ठीक है? तो यहाँ पे कोई स्ट्रैटेजी काम नहीं करेगी एज़ सच। ये कॉम्पिटिशन है, ठीक है? But tell in English. Okay, so Shiv was asking about strategies for studies. So I was telling him there is only one strategy for competitive exam like IIT JEE, which is clear fundamentals and practice. That's about it. Because of the competitive nature of the exam. So if people are telling you this is the strategy to get top 100 rank, that is just not to use the word, but that is essentially a lie. Okay. So you can have strategies to get, let's say, 90% marks in boards. That is fine. But in a competitive exam, you realize in boards you are happy if you got 90%. Hai, even if thousands of people got 90% plus, doesn't matter, right? In a competition, it matters. In a competition, to do well, you have to do better than others. So if there are so many strategy videos on YouTube, where people are claiming that you follow this strategy, you will get top 1000 rank. You follow this strategy, you'll get top 100 rank. And lakhs of people are viewing it. Lakhs of people are watching that. So do you think that strategy will work? If 1 lakh people are trying to use that same strategy to get a top 100 rank, can 1 lakh people get top 100 ranks? No, of course not. So those things never work. There's some just again, I don't want to use the word that I find appropriate to describe that, but there is only one strategy. Forget about all those things. Those are time waste. One strategy only: clear fundamentals and practice. That's about it. Yeah. All right. So that was our talk about the rise of liquid here. So what happens is that again, as I said, the liquid gets pushed and the radius or the angle of contact will change. Okay, and it will change such that the new height h dash would be equal to 2t cos half 2t cos theta dash over rho rg. So okay, in such cases theta dash changes, the angle of contact changes. Okay, it doesn't remain the same. Angle of contact changes, adjusts to maintain equilibrium. Okay, and the liquid will never overflow because overflowing of liquid would cause violation of. Okay. Next, again, we will also want to talk about where is the energy of capillary rise coming from. Okay, where is the energy coming from? So some of you, let's say if the liquid has this level initially and liquid has come up here, so it has gained some potential energy. Where did that potential energy come from? So let's talk about capillary, the energy concentration of capillary rise. So where is the potential energy that the liquid is gaining when rising in a capillary tube coming from? Which app you're using for teaching us? Okay, so uh, I have my iPad, so I am teaching you on my iPad. So there is an app called Notability. Okay, so I'm writing on Notability. These are PDFs, and I can write on PDFs. Okay, using this Apple Pencil and iPad. Okay, does that help you, Mr. SKS? Okay. So where is that energy coming from? So some of my students say that, sir, this atmospheric pressure will do work, and that is maybe causing the rise in potential energy. But no, you will realize the whatever work atmosphere is doing in pushing it here, the same amount of negative work is being done on the atmosphere when the capillary rises. Okay, I hope you remember the work done by atmosphere on any section is P delta V. Now you realize here the force is downward and the volume here is decreasing by some delta V, and the same amount of volume is rising here. So the net work done by the atmosphere on the entire liquid is zero. Net work done by atmosphere on the entire liquid is zero. So then who's doing the work? Where is the energy which the capillary is gaining coming from? And of course, capillary is gaining energy, by the way, because you realize if the area of cross section here is so, you can also say, sir, this section, are you teaching offline? I want to join you. Okay, not currently, but maybe soon now. Okay, I'm not teaching offline anywhere. Maybe in the near future. Now, some of you can also say, sir, it is the potential energy being lost by this liquid. No, that is also not the correct answer, because you realize the area of cross section is so huge here that the change in height is hardly anything. Yeah. So again, so where is this energy coming from? Turns out, if the liquid does not rise, when the liquid does not rise, so you realize you just dip the capillary. If you just dip the capillary in this liquid, what happens is that there was a free surface between solid glass and air. Okay, there was a free surface between glass and air. So this surface also has free energy. So this was free surface. So also free surface, which also has surface energy. Now, when the liquid rises, this free surface is gone. Okay, so the surface energy of this is what is getting converted into the potential energy of the capillary. Okay, so SKS, where are you located, by the way? Where are you located? Where are you guys located? So you will have to move to Delhi because I am in Delhi. So if at all you want to ever study from me offline, then you will have to move to Delhi. Are you guys in Delhi? So if you guys in Delhi, maybe I can help you with the offline studies then. Okay. So what you realize is that this is important. Write it in blue only. Energy gained by the capillary rise comes at the cost of free surface energy of glass. Okay, so please note. So that is where this energy is coming from. And that is why you realize if you Gujarat. Okay. All right. Wow. Okay, that is interesting. So okay, then I'm sure I'll have to think about this thing. Okay, for maybe I should start teaching offline if so many of you want to study offline. है ना? All right. Hmm. So maybe I can plan something there. Okay. So you can realize that the energy gained by the capillary rise comes from at the cost of the free surface energy of the glass air surface. Okay. Now that is the reason why in a capillary of insufficient length, the liquid could not have risen any further, because once this free surface ends, there is no more energy available for the capillary to rise and gain potential energy from. Okay, and that is the reason why, again, if I assume the liquid to be overflowing, then that would be a violation of energy conservation. Okay, now I can conclude that that is why uh, liquid cannot rise, not rise in a capillary of insufficient length. Capillary of sufficient height. Okay. All right. So now let's practice some problems and end this session then. That is all the discussion that I wanted to have about capillary action. Okay, I have discussed all the concepts. Think I hope you followed every discussion. Okay, now let's practice some questions and let's see. Let's see. So here you will realize that mercury has a contact angle of 120 degrees with glass. A narrow tube of radius 1 mm is made of this glass is dipped in mercury. By what amount does the mercury dip down in the tube relative to the liquid surface outside? Surface tension of the mercury is given to you as zero point 0.5, and the density of mercury is also given to you. The acceleration due to gravity is also given to you. Okay. Now you will notice one thing, that in our equation of height, you realize you have cos theta. Now, this cos theta can be negative also. You realize if theta is greater than 90, in fact, cos theta will be negative. So you will have negative height. Negative height would mean that the liquid is getting depressed. And positive height would mean that the liquid is rising up in the capillary. So let's make a note of that here. Since cos theta, you realize your angles of contact can be anywhere between 0 and 180, theoretically. So cos theta can vary from, can be positive or negative. Therefore, H can also be positive and negative. Okay. A positive H means rise in capillary, and negative H means depression of liquid in capillary. Okay, so the signs are already telling you whether the liquid will rise up or it will go down. Okay, so now let's try this. Again, a very simple, straightforward formula-based question. Sir, I have joined you recently watching your lectures. Can I crack JEE Mains in advance in online mode? Because in offline, I'm sure that I will crack. So yes. The problem is that in online, I think a small problem is that students and teachers do not get to interact as well, and that is why I'm not able to keep track of your progress as well as I could in any offline setup. Okay, so that's the only difference, I think. Okay, but if you can manage that somehow, then definitely you can definitely crack your JEE. Okay. Next, for any other queries, what you can do is you can reach me out on Telegram app if you have that. So my ID is @Rohit_Dixit. You can reach out to me on Telegram. Okay, so you can connect with me here and maybe I can help you better there. Okay. All right. So why don't you try this problem then? Will you get in touch with me there and let's see. We will discuss what we can do. Okay. So that goes for you also, Shiv. Shiv and SKS, both of you guys can get in touch with me on Tele, and then we'll see. Okay. All right. All right, no problem. Now, again, this is a very simple, straightforward question. As I said, all you need to do is use this formula. That's it. Substitute all the values. 2 into t was 0.5, I think. Yes. 0.5 into cos of 120 would be minus 0.5. Okay, over rho was 13.6. 10 to the power 3 into r. Radius was 1 mm, so 10 to the power minus 3 into 10. Okay, all you need to do is solve this and you would get the answer. Okay, as simple as that. Next, let's try one more. Water rises in a capillary up to a height of 2 centimeters, and in another capillary whose radius is 1/3 of it up to. Okay, so if in a certain capillary it rises to 2 centimeters, in another capillary whose radius is 1/3 of it, what will be the height up to which the water will rise? Okay, so this is very, very simple. Also, if the capillary is inclined at the 60-degree angle to the vertical, then what is the length of the water column in the tube? Now, this is another very interesting thing. What happens if you incline the capillary? Okay, if you make the capillary like this, then what do you think will happen? Again, if you remember, that is why that alternate derivation was important, the pressure derivation. So when we derived this proof with the help of pressure, now you will realize, so you can't make the FBDs now. Why? Because there will be normal reactions due to the tube, correct? So if you wanted to now calculate the height or using the FBD thing, then you have a problem. But what you realize is that if you still apply the pressure thing, now you don't have an issue. You realize that again, because of the pressure, the meniscus will yield the same pressure, and you realize the vertical height would remain the same. So even in an inclined capillary, the water will rise to the same vertical height. Please remember that. So that the pressure again, because you realize the pressure equations will, this would remain the same, this would remain the same, so this would remain the same. So in an inclined capillary, the water rises up to the same vertical height. Please remember that. Very, very interesting situation. Okay, so again, this is very simple. You know that since h is inversely proportional to r, so h dash जो new height होगा वो क्या होगा सीधा 6 centimeter हो जाएगा. If in one capillary the water can rise up to 2 centimeter, in the capillary of 1/3 radius it will rise 3 times. Now also, if the first capillary is inclined at an angle of 60 degree, then what will happen is if you incline the first capillary at an angle of 60 degree, okay, I don't know, let's hope this. The vertical height would still be 2 centimeter. Vertical height would still be 2 centimeter. Okay, so again, probably you are inclining it to the vertical. Okay. When you're inclining it by 60, so you are inclining it with the vertical because it was vertical initially. Okay, so what you will realize is that the length of the water column here, so column ऐसा हो जाएगा, and it will go up to a length so that the vertical height is still 2 centimeter. Okay, so what you will realize is that if L is the length of the column, then L times cos of 60 is 2. So L would be L cos of 60 equals 2 centimeters. So L would be 4 centimeters. Okay, so the length of liquid column in an inclined capillary would be 4, so that its vertical height still remains 2. Okay. All right, this is yet another very, very interesting problem. A capillary of length 1 meter is placed in a vessel containing water, and the level of rise in the capillary was observed to be 10 centimeters. Now the entire setup is taken to space. The new height of water column in capillary will be seen as a 0 centimeter, 10 centimeter, 100 centimeter, or water will start overflowing from the capillary. So again. This is a problem that, in fact, I want you to think about. So let's leave this as a poor problem. So think about this problem and leave your answers in the comment section. Okay, leave your answers in the comment section. I'll discuss it in the next class. Okay, this is a very interesting situation. Okay, if you take this capillary filled capillary and the water source to a gravity-free space, what will happen? All right. So with that, let's wrap up today's session. Okay, and before I take your leave, let me just quickly remind you that if you haven't gotten your plus subscriptions and if you're planning to, then this is how you go about that. You can go to the plus section of the app and select your goal as IIT and click on the get subscription button. Okay, and once you do that, you will be redirected to the payment page where you can enter this code RD Life. Okay, so you'll realize this code will give you a 10% off on all your subscription fees, whether you select the plus subscription or the iconic subscription. Okay, next, when you click on proceed to pay, you can also select a lot of no cost EMI options to choose from to break these payments into smaller parts. Okay, next, you can also go for the iconic subscription, which will take your IIT JEE preparation to the next level by allotting personal coaches and giving you these extra benefits apart from your plus benefits. Finally, for students who have just entered class 11th and are worried about how to go about their preparations, they can choose combo subscriptions, which will take care of all your study needs for the next 2 years. There are 4 combos that you can choose from. First combo offers you the iconic subscription for IITJ and a class 11th and 12th subscription for plus. This combo starts at 4,600. The next combo offers you iconic for all three. This combo starts at 500 a month. Next combo offers you plus subscription of all three. This combo starts at 3,000 a month. Finally, you have a combo which offers you the plus for IITJ and iconic for 11th and 12th. And this combo starts at 3,900 a month. All right, the students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using so that you are receiving all the time notifications of every lecture and session which is happening here. Right. Now, again, okay, I missed one slide, I think. If you like today's session, then do not forget to press that like button and share it with as many people as you can. Okay, and if you're new to the channel, don't forget to subscribe and don't forget to hit the bell icon. For that, let's take your leave and let me finally remind you that this is one code which you can use in multiple ways. So this code will unlock free features of Unacademy app. You can also use this to get a 10% off on all subscription fees. So be it your plus, be it your iconic, be it your combo, all subscription fees. And you can also enroll all Unacademy events. So, okay, so one code, multiple benefits. All right, with that, let's take your leave and I'll see you shortly. Till then, you guys keep studying hard, keep practicing hard, and take good care of yourselves. Bye bye.